Hey guys, welcome back to the Bayside Fabrication YouTube channel. As you can see, I am all moved in my shop. I just have a few more small things to do. One of them being moving my tool chest back here. This is actually a washer and dryer that this is going to that location, and I bought a stackable unit that is going into my master bathroom. So we're getting all squared away and everything's looking good, but I want to try to change gears in this channel a little bit. You guys obviously know this car quite well, but I want to get more into how-to videos. Honestly, I've looked at the best videos, the most viewed videos that I put out, and they're basically how-to videos. So why not continue that? I mean, this car's awesome, it's fun, but the reality is I might get 1,000 views and per video or whatever, and that's awesome, and you guys are rad to support that, but you know, more people are interested in when I'm building something. So I'd like to appeal to that audience as well. So not that we're gonna get rid of the cart content or anything like that, but I would like to do more how-to videos. And if you guys want me to see, if you guys want to see me build anything, please leave a comment below. Show me what you guys are interested in, and I'll be happy to tackle any reasonable project that comes around. So today we're building an air-to-air intercooler, and this is gonna be our third how-to video. So let's build it. But today I want to show you guys how to build a air-to-air intercooler. So Jonathan from For the Performance has a K-swapped S13, and he's gonna be moving as well, so he kind of ran out of time to build this himself, so he asked me if I'd do it, and I said sure, it'd be a great little project. So first thing you need is your intercooler core. This one is made by Treadstone, and this core measures 18 by 12.5 by 3.5. So let me show you this core and how it works. It's just like any radiator or anything like that, except this is designed to move air through it, not a liquid. So going this way, through this part of the core is your air. You know, when you're driving down the road, the air passes through here. And then this air right here is your charged air. So one side is gonna come in hot. It's gonna flow through these rows, and these veins here dissipate the heat from that. And then out here comes your cold air. So hot air in one side cools down from the air flowing through it. Colder air comes out the other side. That's the whole purpose of a intercooler. So what we need to do is make end tanks for these. So there's got to be under pressure, obviously, because it's turbocharged application. And so we need to make sure these are all welded perfectly tight and sealed and can hold, you know, 50, 60, 70 pounds of pressure, no problem. And what we have is a sheet of 1/8 inch aluminum, 0.125, 5052 aluminum. We have our tank fittings. So these are going to go to the from the turbocharger and then into the throttle body. That's what these are for. And then we have, well, you can see I sheared up one side. I actually made a intercooler last week for another car, and it uses the same width end tank, so it worked out really well. I was able to kind of steal this template. But essentially that's just you know, half of one of these end tanks. So you kind of get the idea of how this works. And he wants this actually bent, and I'll just show you what I mean by that. But essentially we're gonna bend a piece to kind of have the flow kick in this way. But it's hard to explain, but you'll see exactly what I mean shortly here. So I want to go over these clamps real quick. These are Vangen style clamps, and you know, Vibrant calls them their HD clamp assemblies. These are really nice. They're also almost $200 a piece, so there's that. But these have this cool pin with this detent here that locks everything in, which is awesome. But let me show you how they work. So there's actually 2 O-rings that come with them, and those O-rings sit right in these grooves here. And then there's this band that wraps over it. So imagine the O-rings are sitting in there and it's now tight against this band. Well, then this clamp, I gotta get the band here. There we go. So then this clamp fits over, locks that band, pressing the O-rings and sealing perfectly. Now what's really nice about these is I believe it's like 12.5 degrees of total play. So if you're not, you can kind of, move these around a little bit. If your charge pipe is, flexing or anything like that, there is a little bit of flexibility here, which is really nice. These are far superior to just your basic silicone couplers. I mean, you're not going to blow one of these off. The only way you can have failure is if the O-ring fails. But I can't remember what pressure they said these are rated for, but some ungodly amount. So these are really the way to go if you can swing them. So I'm happy to work with these because they're awesome. But as you can see here, he wants 2 different sizes. He was going to do 2.5-inch inlet and 3-inch outlet on this intercooler. So we have the respected sizes, and yeah, those are Van Gen clamps, really cool, and they're going to be awesome. So let's get our end tanks sheared up. I already cut one out. This one measures 4.5 inches. So we have 18 plus 4.5 plus 4.5. That's going to give us 27 overall width. So we'll have approximately 3/4 of an inch to spare on either side. So there'll be plenty of room for this to fit his particular application. So let me make a couple more of these, and we'll show you how we're going to design these end tanks. So what I use to shear is this little 12-inch bench shear. This works really great, actually, and I use it for all sorts of things. But it cuts aluminum really well. So what we're going to do is just obviously shear along the line here. If you don't have a shear, you can actually use a jigsaw, or I mean, I've even seen, 1/8 inch might get a little dicey, but you can actually even use a table saw in some situations with aluminum. I don't recommend it, but this is really the best way to shear aluminum. So we just adjust our little stop there, and we're going to cut right on the inside of this mark. Easy as that. So one of the downsides to a shear like this is when you cut something off the back side of that. For example, I sheared off, actually you can see I sheared off a piece this big to create one of these, and you can see it actually curls the material slightly. So in this situation, it's not a big deal because we're actually going to be clamping on this flat surface. So it'll get rid of that curl, but that's something just to consider when you're doing work like this. It can kind of get the, if you're shearing, it can kind of get the material a little wonky, but it's very fast and effective way to get results here. So now that I have 2 end tanks sheared off, I have to make the end caps. So, and they're going to be the piece that comes down and seals the whole thing in. So what I am looking for is essentially I just need to cut out a flat piece and bend it to this profile, but I need to get this width here. Now this is a 3.5 inch core, so if we do it exactly at 3.5 inches, we will have a 1/8 inch overlap here on the end tank, which would work fine, but I'm shooting for more of like a 1/16 overlap. It just create a nicer weld, and it won't have these big fat looking end tanks. It'll just be kind of a little more subtle. So what I'm going to do is cut this width here at 3 3/8. So that'll give me a 1/16 on either side, and that's the measurement I'm looking for. So right here we're marking our 3 3/8. Now, it's actually important to note, if you're using a Sharpie like this, which side of the Sharpie line you're on. This is actually not a brand new Sharpie, so you don't actually have a really fine line. And this is almost a 1/16 of an inch in width on the line. So when I do stuff like this, I either go on the inside or the outside of the line as far as the measurement's concerned. In this application, 3 3/8 is going to be on the outside of the line. So when I shear it, I'm gonna favor the outside of this black line. I know it sounds silly, but you know, if you're on the inside of one line, 1/16 of an inch, and then on the other line, let's say you're on the outside, well, that's an 1/8 inch now that you're off on what you really want to be. So it's just a good idea to remain consistent in something like this. Well, there we have it. Now, like I was saying, this is a great tool to have around the shop. It only costs like $120, I believe. This is kind of like it's a Chinese one, but it's just such a nice thing to be able to bang out a piece like this in, you know, a couple seconds here. So, okay, so let me show you how we're gonna measure this out here. It's very simple. We're gonna hold it flush here. In our first bend, it's going to be right there. So we're going to bend this now at, which is a 45. We're going to bend this at a 45, mark the next one, bend it, bend it, bend it, and then we're going to have extra material laying coming off the end here, so we'll just be able to shear that off at the very end. I made these long on purpose. So what we're using to bend this is our Swag Off-Road finger brake. This is a great little piece. You can only bend up to, I forgot what it was, 18, was it 18 inches? 19 inches. So you can only bend up to 19 inches with this, but it's fantastic, and it's designed to work with the Harbor Freight 20-ton press. I opted to do a air over hydraulic on this, which makes it really nice, so you're not sitting here, you know, wrenching on a stupid bottle jack. But you'll see how this works. It's really slick, and I forget how much this costs, but it's worth every penny if you're doing anything remotely close to this kind of work here. So let's get this bent up. So the only disadvantage to this is it's hard to kind of see on the back side. We give the old eyeball. As you can see, we got a little ways to go here. All right, so that's slightly overbent, not a big deal. Just throw it back in here and that's more like it right there. So now we have our second bend marked up. We're gonna bend that, and we're just gonna repeat the process here. All right, we got this piece bent up. And as you can see, this is kind of how we want to sit. We want this nice 45 here to weld. And you can see, like on this part, it doesn't really give us that. So what I do is just go, it's not marking right. We're just gonna nip these corners off a little bit just to round off the flat piece here. And that'll give us a nice roll around on the aluminum there when we weld it. So I do have to modify this end tank profile here, and I'm going to show you that right now. The customer wanted to have them beveled. So what that means is we're going to taper off the end tank on either side, and that will direct air to go in and out of the intercooler faster, essentially. So I went 1.25 inches here. So now we're gonna cut out my modified bandsaw. This is just a little, what was it, 5x7 bandsaw. So this is normally a horizontal bandsaw, and I modified it to sit upright. That way I can cut little pieces. The only problem is I can only get like a 2.5 inch piece through here clearly. And so that's the real issue with having this setup. But it will work perfect for this because this is only 1.25 inches. So let's get this chopped out and I'll show you how it's gonna look. So that's it. So now all we have to do is make this beveled piece. So what I'm going to do is trace this as a template and extend this out about another, oh, I don't know, 3/4 inch, and then we'll trace it, as you'll see in a moment, and chop that piece, and our end tanks are almost finished. All right, we just tacked on our one side of our end tank here, and now we have to make this bend here. You could, just do straight piece and weld, but it's just not that clean looking. This has just got to look way better. So what we do is we just mark it right at that bend, which I've already done, and we bend it. All right, just bent this piece up. It's hard to do it with one hand here. So now we're just going to line it up where it wants to live, and then trace out. I'm going to use a pencil for this to get a nice sharp, you know what, I'll use a scribe piece to get a nice sharp line. Get lined up. All right, just doing a little test fitment here on this end tank, and it looks like it's going to go pretty freaking sweet. So what we need to do now is to drill our holes, and we do that not when it's tacked on or anything, because we don't want any crap getting into the core, because if any little bits of metal shavings get into here, it will ultimately more than likely find its way into the motor. So it's very important to keep shavings and stuff like that away from your intercooler inlet or outlet. So let's get these going. So we have a 2.5 and a 3-inch Van-Jan, and I simply just bought a 2.5-inch hole saw. So that will work for that one. And then I bought a 3-inch hole saw for that guy. And there's our 2 holes. So let's get these knocked out. All right, we got our holes drilled, and all we gotta do is deburr the little lip around here. So as you can see right there, sometimes you have to get a little creative. What I do is I use that clamp as a kind of a pry bar, because I had a little gap here because this was just slightly twisted. But you can see we got a nice fitment all the way around, and that's what we're really looking for here. All right, guys, well, this side's tacked together, ready to weld. And it's coming out good. So we're gonna do the same exact thing on this side, and we're gonna get this thing all buttoned up. All right, guys, our intercooler is all tacked together and ready to weld up. See how we have these nice fillet joints here? And this is gonna weld up beautifully. So just to show you guys what we're gonna use to weld this is I'm using my AHP 200, what is it, DX? It's a 200X. This is the, this is a cheap AC/DC inverter machine, Chinese made. I've had this for like 4 years now, and this thing just runs awesome. The only issue I have is the amps readout is not accurate, so it just kind of fluctuates, goes all over the place, but I leave it at full bore for mostly everything anyway, so it's running at full 200 on the pedal. What we're using for our AC balance and our AC frequency balance is approximately 30%, and the frequency is right around 60 hertz. So that's what we're using for that. For the torch, I have a water-cooled torch. You can see I have a ghetto water cooler, which I'm actually going to be making a really nice aluminum one out of, but that's just a fish tank pump in a 2.5 gallon bucket of water for now. And we're using a Furic number 10, Furic Jazzy number 10 cup with a screen and a 3/32 tungsten. For filler rod, we are going to be using 5053 filler rod, and it's time to party. So we're gonna get all set up here. I just whipped together actually this hood system, and it's just a axial fan vented right out to, right out the window here. So that should hopefully collect most of the fumes and stuff in this small space. Having a low ceiling really sucks, but it's the way it goes sometimes. So we got a nice thunderstorm going on outside, so I hope we don't lose power when welding this, but we're gonna hammer this thing out and it'll be done shortly. Alright guys, that does it for our intercooler project. We got it all finished up. Everything came out real nice. All the welds look good. Everything was clean, no issues. Just a nice little intercooler we got ourselves here. So, thank you very much for watching, and if you guys want to see me do more of these how-to projects and what I should be building, please leave a comment below. I think I'm gonna, they've proven to be the biggest part of my channel, so I think I'm just gonna expand on that more. But if you guys have any ideas of what you'd like to see, what you'd like to see me build, as long as it's not some like crazy project, hey, build a whole tube frame chassis from the ground up. I just don't really have time or space dedicated to that right now. But projects like this, we can definitely knock out, no problem. So just let me know what you think. And if you have a custom intercooler you need made, feel free to reach out, because for me, it's a great little deal. It takes, just a few hours to knock one out, and they're really fun to do. So I enjoy working on them. So if that's something you're interested in, feel free to shoot me a message as well. Bayside Fabrication on Instagram is probably the best way to get a hold of me, and maybe we can work something out. But In the meantime, I appreciate you watching. Thanks for taking this little journey with me. If you have any questions, feel free to ask them in the comments. We'll see you on the next one, guys. Thanks a lot.